Hello all, welcome to my channel. So today we will learn about LTSPICE simulation of the differentiator circuit. So first we go to schematic, new schematic, and we search for components, op amps, and then we select OP07. We place it with the left click. Then we will use voltage source for supply voltage of op amp like VCC and VE. So we have used two voltage source and that we will give supply later, that is 15 volts and minus 15 volts. Now we use wires to connect these supply voltage, and because this op amp has OP07 has two terminals, you can see here, plus and minus. So we will also connect these voltage source with that terminal to V1 and V2. So V1, V2 are actually voltage source names, and the V written down there is the value of these voltages. So any component in LTSPICE, you have name of that at the top, and at the bottom you will write the value of that component. Okay, so later we will write the values as 15 and minus 15. Okay, but we have taken the same polarity, that's why both are in plus. Okay, now we'll take a resistor and we will rotate it, because you can only place it like that, so we will use control plus R. So we have taken two resistor. Why? In capacitor circuit, what you have feedback resistor. Okay, so you have RF and you have capacitor and the input side. Okay, so here you have used C1 and RF. And what is the output of a practical differentiator? Because we are drawing a practical differentiator, the practical differentiator output is minus RF C1 differentiation d by dt of input voltage. So we will also place input voltage here, but now we are taking four components like R1, R2, C1, C2, and we will replace these names like C2 can be replaced by CF, R2 can be replaced by RF. Okay, now as you can see, we have four components. Okay, now in LTSPICE we will name these components. So I have already told you that the upper part is for name, so I am changing the name here R2 as RF because it is in the feedback path. Similarly for C2 I am changing it to CF. Okay, so you can change it to CF because it is also connected in the feedback part, that is the extra part. Here CF is the extra part and here R1 is the extra part. Okay, now use wires again to connect. So we are making a feedback path. You can see the terminals here. So you already know that op amp has two terminals, input terminals, one is inverting and one is non-inverting, and only one output. Okay, we will later label that net also. Okay, first we will do connection for wires. So we are now connecting the wires. So as you can see, I am connecting the wires. I have connected this RF to C1, and now the RF second side I have connected to the output side. Similarly, CF is also connected, and you can see the black blue nodes here. Nodes means there is a node. Okay, so it represents a connection there. Okay, now there is R1 also, and we will also use ground. So in the upper part you have ground, or you can also search for component, and in the component library you can type ground. You can also do that. Okay, so now our connection is very much complete, but I have already told you that input we are giving at the inverting terminal. So this input is actually inverted, and also because you are giving this input in the inverting terminal, and also this will be differentiated. what does it mean? Because in the differentiator circuit, whatever input you give, if you give ramp input, it will be differentiated. If you give sine input, it will be differentiated. So you can see that. Okay, you can also give a variety of inputs like pulse input and all that. Now I have used two ground, and I'm making a connection here using wires, so that voltage is ground, and also the plus terminal, that is the non-inverting terminal of our op-amp op07, is also grounded. Okay, now there is a slight thing, so we have to move that ground to a lower part. So if you want to move that component, you can go to edit and then select move option, and then you can move up and down that component. Okay, so now our connection is almost complete. Now we will give values to our four resistors capacitors combination. So I have given R1 is equal to 50 ohm, so I have written 50, and in the C1 we will give it as, you can give any farad, like I have given 20 nanofarad. And similarly we will give the values of RF and CF. So what will be the value of CF? I have given 1 nanofarad. You can change it as per your convenience. Okay, and R is actually generally large, so I have given 1 kilo ohm, so I have written 1k. Now there is one remaining connection, that is also I will place ground here, because I will also write the values of the supply voltage. I have not written that. You can also change the V1 V2 here as VCC and VEE, and then give the voltages, the supply voltages. And suppose I am giving 15 volt, so I will write it in the place of V we will write 15. Similarly, in the place of V2 and we have given VEE as 15, because they are connected in the same polarity. So I have written 15 both sides. Now I am writing the value of V3, that is our advanced, and I am giving sine wave. So in the sine wave you can get offset voltage DC offset as 0, amplitude 1, frequency 1k, and that is our input signal which we want. Now we will label our net, and we have not specified where is the output. So I am now labeling it V out, because that is our output. We have to check the output of the differentiator circuit in the LTSPICE simulator. And similarly we will also label net, which is our input side, V in, because we also need to check whatever the input is and what we get at the output. So I have labeled both net, V in and V out. And now when we try to run it, it will ask the stop time. You can put whatever millisecond. I am writing 90 millisecond. So you will write stop time here. Okay, now you will get a screen, a black screen like that, and now you will place the cursor. You will get a red cursor, and you will get a sine wave of 1 volt and 1 kilohertz frequency. Now we can look at the output.